Okay, this is James Jopling again with Shoppa's John Deere, and we're going to review the engine components for our 2021 Tech Challenge contest. So first of all, we've got what's called an air throttle, and it's just like the throttle on an automobile now, the air throttle on an automobile, except just a bit larger. But anyway, the first question is true. When the air throttle valve is closed, a negative pressure will be noted in the intake manifold. Yes, because it's going to be closing and blocking off the airflow, so it will generate a negative pressure. So the next question is true. The air throttle is controlled by engine control processor. That's true. ECUs on automobiles, diesel engines, just 99% of applications, and even on a lot of the lawnmowers have the engine controllers or engine processors now. The next question is false. The air throttle is normally closed. No, normally it's in the open position as such. Now the next question, the purpose of an air throttle is to close to increase the exhaust temperature for DPF active regeneration. On our newer engines, we have emissions, of course, so it's got to go into DPF cleaning for regeneration. That's just a cleaning process for the exhaust filter, so to speak. So that's true. Now, the last question is false. The air throttle is volumetrically controlled by airflow. No, there again, it's controlled by an ECU, a control unit, a processor, and it's actually got a servo built into this, which manipulates that air throttle. But anyway, that is all concerning the air throttle. Now, for our next component is a turbocharger, and this actually, if you read the principles, turbocharger just simply is exhaust driven, and the greater the amount of exhaust gases, the greater the intake turbine, which is this side, the faster it's going to spin it, therefore it's going to pull fresh air in here, and it's going to actually take it and boost that going out. And usually it goes through an aftercooler because it does become exceedingly hot. Now this particular one has what is described as a wastegate. So we can actually dump some of the exhaust gases or restrict the exhaust gases to where it'll slow this intake turbine down. But anyway, first question. As power demands increase and exhaust gas volume increases, the turbo exhaust turbine speed increases, thus increasing intake turbine speed, therefore increasing intake manifold pressure within the combustion chamber. There again, that's true if you study how a turbo actually functions. Next question is false. The air intake turbine should always remain at a constant speed. That is inaccurate. That intake turbine is going to be, the speed is going to be controlled by the exhaust volume. The more exhaust gases, the faster the exhaust turbine, which is in here, the faster that's going to be spun, therefore it's going to increase the velocity of that intake. Now the next question is false. Supercharger and turbocharger are driven by crankshaft drive belt. Turbo is exhaust driven, and a supercharger is in fact mechanically driven, either directly by gear drive or by a belt. The next question is true. If there's restriction in the exhaust after the turbine, the intake turbine speed will be proportionally diminished. That's true. There again, if we have a blockage in the exhaust gases coming out of this exhaust turbine, then it's going to start minimizing the speed of that turbine, therefore it's going to reduce the speed of intake because they are coupled with the shaft. Now the next question, the final question, a turbocharger increases air volume to continue equal balance of fuel-air mixture within the combustion chamber. That's true. And that is all of which we have for the turbocharger. Okay, our next component is just a basic simple fuel injector. This is a pencil injector. It has been used on engines, many engines over the decades. Very, very reliable and relatively inexpensive. Okay, the first question, if the compression spring D breaks, too much fuel will be displaced to the cylinder. That's true. In this, if this spring breaks, then this plunger, which is inside of here, is going to open up and allow just raw fuel to be pumped into the cylinder. So that is true. The next question is true also. If the plunger, which is that little dude right here on this picture, if the plunger is bound closed, no fuel will be displaced to the cylinder. There again, there are multiple little tiny orifices in the tip of that, and that plunger has kind of a needle looking seat, and it's going to actually close inside there, and it's going to close passage to the orifices, fuel. So if it's stuck closed, then you're not going to get any fuel displaced to the cylinder. Now the next question, if this fuel injector can only be controlled electronically. No. This is strictly a mechanical injector. There is no electronics involved in this injector whatsoever. The next question, again, is false. If the fuel injector return line ruptures, the injector will fail. No, the injection return line, all that is the excess bleed off going through that injector back into the fuel tank. So that's not going to have any bearing on how that injector is going to function. Next question is true. High pressure fuel is displaced from the injection pump and sent to the injector and overcomes the spring pressure with the injector unit, thus allowing the plunger to move up and discharge fuel. That's true. There again, it's going to be as such. Then you're going to have fuel that comes in. It's going to push against this, which is finely machined. It's going to push it up and allow fuel to pass, and then that's going to slam back closed, and it'll force it through the orifices and the tip end of it, atomizing that. But that's it that we have for the fuel injector. The next component that we have is a piston, just your basic piston. I think most people are quite familiar with them. Now the first question is false. This piston can be reused with no issues. Now we've got skirt damage on one portion of it and pretty significant skirt damage over here, but you do have a little scuffing, a little scoring on the side of the skirt. So no, that piston cannot be reused. The next question, there again, I think I basically answered that, is false. Damage to piston skirt is not going to influence longevity. So no, this piston is not reusable. The next one also indeed is false. This piston is not reusable due to weak rings. Well, the rings are probably weak, but you could potentially change the rings, and if that was the only problem, if that was the only issue with this particular piston, you could potentially reuse it. Okay, next question is true. The observable damage to the piston may be caused by lack of lubrication. Yeah, scoring many times is lack of lubrication, or such as we've seen before in our profession, lack of maintenance, which leads to lack of lubrication. Okay, next question. Damage to the piston could possibly cause an imbalance issue, which could potentially lead to failure. Yes, that's true, especially with skirt damage. It can cause it to have imbalance, and it could definitely lead to engine failure. And that is all that we have for the engine components.